Welcome back. This is part 3 of my map tutorial. And this is where we left off. We have our basic map. We have our realms, cultures, religions that we can show on the map. We have rivers and towns, trade routes everywhere. And in this part of the tutorial, I will show you how we will refine the map and add some more details and some more information to it and fix some of the problems that we have with it right now. So let's get into it. The first thing that we need to do is we want to fix some of the placements on this map. And if you look at it more closely, you will notice that at the moment the map has some problems where things don't line up exactly. For example, here is a way that doesn't quite reach this town here. So we will go in and we will just fix all these things. And we can do this very easily in QGIS. Just select the layer that you are working on, then select edit, and then you can work here with the vertex tool to change everything. You can select any of these vertices to drag them around, or you can, with this little plus, add a few more. And if you have snapping on here, it is very easy to reach this town exactly, and otherwise it will snap to the existing point. And there we are, that's beautiful. We have similar problems with these crossings of rivers, which frankly speaking could be better. So we will add just a few points here, just turning snapping off for this. We will really not change how it is, but add points in between here, just to add this bridge over the river at this point. Then we have some places where we have such strange crossings and we will just want to drag out the road a little bit so that it follows the river here, but doesn't come over it really. And this we will do as we go over the map. You can do it in one big effort in the map, in all of the map at once. Or you can do it as we work on the regions. Then I mentioned it already that sometimes rivers don't line up exactly, so we want to save this. Exit edit mode, we now go to the rivers layer, and again we use this vertex tool to connect these, snapping on, to connect these here so that everything lines up nicely. So this is just basically fixing problems that we have. Another common problem that we have, and that is all my fault because I wrote the GeoJSON exporter for ASGAR's map tool and I set the value too high for rivers. You will see this if you go to edit mode and the vertex tool, and you see that they are really made up of a very dense number of points here. And that's only needed in a few places where it makes really tight bands. Even here it could be less. So we usually don't need this sheer number of vertices. Fortunately, that is really easy to clean up. We just go to Vector, Geometry Tools, Simplify, and then we set the tolerance here. Use a really low value. Usually use something like this. And then we have a new simplified layer here. And if we go into that layer, we can see that now the density of the points, it's much reduced, despite you don't actually see much of a difference in how the river runs. The ASGAR generator unfortunately doesn't take into consideration is that in the real world, most of our cities would be at the rivers. And some of them are, like here and here and here. This is nice. But many of our cities are strangely a little bit away from the river, which doesn't really make much sense. And this, for example, this town would be at the coast, probably. So we also go into the towns layer, we find these places, again with the vertex tool, we can just select them and just drag them over here. And then we also go into the routes. You can have more than one layer set to edit mode. And we will turn this road over so that maybe this is a coast, maybe this goes along the coast here for a little bit, like so. Then add a few more vertices for creating a more soft bend, whatever you want to do here. So this is just fixing our placement of towns, fixing the placement of rivers, and you will see this all over the map. And I generally don't work over the whole map at once, because we will go into our wiki and add text descriptions and so on. And when we do this, we will be thinking about reasons for placement and why this town is here and so on. And that is a good opportunity to also change the placement and come up with reasons why it's here or why it's not, and then adapt the map accordingly. But just to show you this, for example, here this town would probably be here at the river mouth. That's a very popular location for cities. And then we just bend over this road here. Now that's what we will be doing. So fixing up the map and making sure that everything makes sense and gives you a realistic map, a believable map. That is a step that you should definitely do. You will profit from it in the long run. It will make the map much, much more believable. So this is the first step of cleaning up that we will be doing. Never forget to exit edit mode and save all your data. Our next step is to add more beautiful borders between the realms. And the reason that we do that is if we go into Mapbox or if we go into QGIS and we just add an outline to the polygon, we also get these effects that we have outlines at the coasts, and if I find a lake somewhere, we will have the same problem there. So you could want this effect, but usually you don't. So we want to have borders between the countries that are only shown on the land and not at the ocean or lakes. So we'll pick our states layer, we go to vector, geometry tools, polygons to lines. And we will just run this, and this will give us, let me turn this all off, and this will give us just the outlines. So far we haven't gained anything. We still have these outlines at the coast here, but we are now going to remove them. So we are going to add a temporary scratch layer. That should be a polygon. And we will zoom out just a little bit. And what we do is we just very fast in edit mode create a polygon. Just a big rectangle around the world. The only important part is that it covers everything. Next, we will go to Vector, Geoprocessing Tool, Difference. And we will use this new scratch layer, and we will use our cells layer and subtract it. This will run for a few seconds, and it will give us a layer that, here we are, it will give us a layer that does not contain land, so we now have an ocean layer here. Now we take our scratch layer and we do the same thing. We use the difference tool, and from our lines we subtract this difference layer, and that gives us a new lines layer that contains only the lines that do not intersect the ocean, so only the lines that are on the land. Now the next thing is something that I have not yet figured out perfectly. I will show you what I'm doing at the moment. And if you can think of a better way, please leave a comment. And if you have another idea what would work, please leave a comment as well. I would really like to make this better than it is right now. At the moment it is a little bit messy, but it works and it gives you the result that we are looking for. It just isn't perfect. So what we want to do is we want to add contours to our map. We want to see these height lines that we know from real world maps where it says, you know, this is 100 meters above sea level, 200, 500, 1000 meters above sea level. This will help us to understand the landscape much better. At the moment, everything seems to be flat and we have no idea if this is a mountain or not. It probably is because rivers flow down from mountains, but there is no indication at all on the map at this time. So that's what we're going to add next. This requires the Contours plugin, which you can easily install into QGIS by going to Plugins, Manage and Install Plugins, and there you will find this contour plugin that installs into this vector. You want the vector contour plugin. There's one for raster data as well. And we will start from our cells data again, because if you look into the attributes table of the cells data, of course, then you see that there is actually a height value stored. And that's what we will be using to build our contour lines. Unfortunately, the height data is stored per cell. And that means that we have sharp edges always exactly at these lines. And also I found it very difficult to tell QGIS to make a line here because it is confused. If I ask it the height of this line, it will not know whether to take the height from this cell or from this cell. So we are using something a little bit different. And what we will be doing is we will go to Vector and Research Tools, and we will use a feature called Random Points inside polygons. And here you need to experiment with the settings a little bit. It depends on your map and so on, what looks good. This is the number of points per polygon that we want to create. I usually start with a low number, and if I don't get the results I want, I will increase it. On some maps I've used up to 50. I will start here with just 10 points. We want to have a little bit distance between the points, something like 0, 0, 1 maybe. And then we will run this. So this now generates random points all over the map, everywhere, and it leaves out some areas here, which is a little problematic. So we will throw this away and do this again. Data Research Tools, Random Points inside polygon. We'll use 15 points and maybe set the minimum distance higher so that they are not clustered together so much. And you know that you've hit a sweet spot when it starts to tell you here in the log that it has exceeded the maximum attempts of placing points. That's a good indicator that you have a little bit too many points, or that your distance is a little bit too high. Then you should decrease it just a bit and you will be good. So we will work with this. It can probably be made better, but for the moment, let's use this for the next steps. Next thing is that we are going to processing and use this toolbox. This toolbox gives you a lot of additional processing options, and we want to find one that is called Join Attribute by Location. And we are using the random points that we just created, and we use the cells as a join layer, and we use the within method. What you're doing is basically saying join these points with the cells and always check in which polygon, in which cell the point that you are processing is located. And we want to add the height field. That is what's interesting to us. This means that it will add the height data from every cell to the points depending on which cell the point is located in. We want to use the one-to-one feature. We want to discard records which could not be joined, and then run. This will take a little bit depending on the number of points that you have and the size of your map. That's one of the reasons why I used a small map for the tutorial, so that this doesn't take forever. On a large map, this can easily take a few minutes. And there we go. So now on this joined layer, if we look into the attributes table, we have a height value for every point. And now we can use this contour plugin on the joined layer. The data value that we want to use is the height, and it doesn't show up here. If it doesn't, that is because it is a string field. And this contour plugin wants an integer field. Fortunately, in the, let me go back to show that you often have this, which means you can add a function instead. So we do have the option. There is a height field. You see here fields and values. There is a height field, and ABC indicates that it's a string field. So what we do is we use the toInt function. I've already done this. That's why it's here in the recent functions. Otherwise, just type it out. toInt from height. So we simply turn the string value into an integer value, and then the contour plugin can use it. We want to create contour lines. We want to use fixed intervals. Our interval is 100 meters. So every 100 meters will be a contour line. It will show you a preview of which contour lines it will create. We have a minimum set already from the last time I used this. You will want to set this minimum probably to 100 to your first contour line, because you don't want a contour line, at the ocean at 0. That is nonsense. And that is all that we need to set here. And we can now add this layer. And there we have it. Now let's turn off these points and see just our contour line layer. There we have it. Now we get an impression of how our landscape actually is. We see that here is a lot of flat lands. Here is a little bit hilly. Here are some mountains where we have many contour lines. And the next thing that we want to do is we want to put a label there. The expression in this, the expression field is actually the number, the height. And if we add this, it should start showing up here. So now we know, okay, here is the 400 meter line. Here's the 500 meter line. This is too small to be shown. This is probably the 600 meter line. And that way we can get some contours on our map. Here's the 600 meters. So here is our small mountain. We can get some contours on our maps. If we pull this above the biomes layer and turn on the biomes layer, then we can begin to get an impression of our landscape. There's probably a more beautiful way to do this, because if you zoom in here, you start to see that it's a little bit rough and edgy, and there are some problem spots which are caused here, for example, by the randomness of the points, and we will have to go in and fix these manually. So now that we have a few fixes applied to our map, we want to add more content, more details. And the one thing that is missing is villages. We have a fantasy medieval world, and there are just towns that very much is not what a real medieval style world would be. There would be villages everywhere between these towns. There would be villages every few kilometers or miles. So we are now going to add some villages to the map, and that's actually very simple. It just requires one step that we need to do before we can do it, because if we look into our cells data here, we will see that the editor stores the population as a text field that tells us, okay, this has 48,000 population, 15,000 rural, and 33,000 in the city. And this is not data that QGIS can work with. So I have written a small PHP file script called fixPopulation. Very easy. It just parses this and translates it into something better. It's also on the DragonEye Atlas very soon, and we can just use this fixPopulation. We take our cell details and we output it. And there we go. And what it does is it takes these population values and translates them into something more useful, namely in integer fields. And it also keeps the rural and urban information for us. So if we now add this as a vector layer, so find our fixed GeoJSON file, add it to the map, we can lose the old one. Okay, now we have all the information that we need. And we can do this for all of the map at once, but for the moment, let me just select a bunch of cells here just so that everything goes faster. We will be using vector, research tool, random points inside Polygon. We will use these fixed cells data. We will use the points count strategy, but here we will not use a fixed value, but we will be using an expression. And what we want to do is we want to find this rural field, and I've already prepared this here. So this is what the expression we will be using. We will take the amount of rural population, we will divide it by 250 or whatever value you want. I'm saying that my average village has about 250 people living in it. Some are smaller, some are bigger, but on average 250. So for every 250 population, I want one village. We also set a minimum distance between the points here. The exact good value depends on the latitude that your map is on the globe. So experiment around a little bit with it. The minimum distance makes sure that the algorithm does not create 2 points directly on top of each other or extremely close to each other, which is what we want with the villages. There will not be one village and then 10 meters away there's the second village. There will be at least 1 or 2 kilometers distance between them. And then we run the algorithm. It runs quickly if you do it for a small part of the map. For the whole map, it will take quite a bit longer. And as you see, we have a lot of random points generated, and each random point we can see as one village. And if you look at the scale bar here at the top, you can see that, yeah, they are actually a nice typical distance away from each other. Now, building on this village creation that we've made, we want to add another detail to the map. At the moment, these villages are just points, and you don't really get any impression of the scale. And also, usually, villages are surrounded by fields, and these are just, points in a forest. That's not what we want. So we will now be adding fields around the villages, which gives us a better impression of the scale, and it also lets them pop out, and it allows us to tell some interesting stories with villages that are away from the road, but there's fields will extend here so that you can actually see the village. When you come along this road through the forest, you will come to a clearing, and then you can see the village in the distance. All these nice details will emerge as we put fields around our villages. And to get an impression of the scale, we first need to set the scale correctly. Maybe you've already seen that I have a scale bar enabled here. If it's not on in your QGIS, you go to View, Decorations, Scale Bar. And we will also be turning on the grid here. But first we need to set the scale properly. At the moment, this is not the right scale, definitely. And the reason is that we are not using any map projection. And if we turn this on, then we can choose our map projection. At the moment, it's using no projection, which means it believes every unit on the map is 1 meter. And the units in the ASCII generator are pretty small because they are not meters. We will be turning to World Mercator for this. You can choose other projections if they are suitable for you, but World Mercator is pretty popular. So when we apply this, everything disappears because we now set everything to the proper scale. The easiest way to get it back is to take one of the layers and say zoom to layer, and here we are. And now we have a first impression of the scale of our map. This is 2,000 kilometers. So this is actually a pretty big continent. We will now zoom in on one part of it. Let's take something at the coast so that we have, maybe a river or a road. You see, these things all need fixing. This city actually is in the ocean. We will not fix this now. We are now here to add some fields. So let's scroll over to a place where we don't have problems. Not just something, anything really here. Okay, here we have a few villages at a river. That looks nice. And we will now start adding fields. We now have an impression of the size, and we see these are maybe 6-7 kilometers away from each other. That's pretty nice. We turn on View Decorations Grid. That makes everything just much easier. And we want to set an interval of 1,000. So this gives us a grid of 1 kilometer squares. So we zoom in until we have a nice size, and we go to our biomes layer, which is also visible. We turn on editing, and then we have a nice feature here, which is called Fill Ring. We enable this. This is the advanced digitizing toolbar. We've used it before. If it's not visible in your QGIS, then right click and make sure that toolbars advanced digitizing toolbar is enabled. So we enable editing mode, we enable fill ring, and then we can just go on our map and we can just click around here and say, let's say, for about 1 kilometer around the village, these guys have made their field like this. Right click to end. Then a small window pops up. We have a lot of information here depending on which fields we kept. The important part here is that we want to call this biome fields. For the moment, we'll just make this red so that it pops out because we set the colors in Mapbox. If you use QGIS or something else, maybe you want to see a proper color value here, or anyway, you use categorized symbology and it goes by the biome. The important part is that you need to store the information that these are fields. And what this fill ring does for us is that it adds these fields not on top, but it actually cuts out for us. So if we select this large region here, the entire biome, this is the, I think, forest. This is the forest of this area. This really cut out this field from this. This is now a separate polygon. This has been cut out, so we don't have a layering effect or set fighting or any such problems. So there is now a small hole in this biome with the fields, and that's what we will be doing for all our fields. So we just go around our villages. Maybe this is a large village, so again, fill ring, we'll say, okay, they go as well to the river, and then it comes out, and this really has, some kilometers of fields around it, like so. Again, we write here fields. This, unfortunately, it always comes up small, so don't make spelling mistakes like I did. But if we go over an entire area like this, we will get a nice impression of the overall layout of the area, which villages are close together, maybe there's fields run into each other, which villages are more distant, where they are clustered, all this information about the lay of the land and how the area is made. One more thing that we want from our map is we want to separate lakes from the island so that we can hide the biomes layer without the lakes disappearing, because on a political map, for example, we still want the lakes visible. And the second thing we want is we want to add some buffer around the edges so that we have this smooth steps where the ocean is more bright near the coastline easily with some tools in QGIS. The first thing is that we will go back to our cells data. This is always our basic for most of our operations. And again, we use vector dissolve. And this time we dissolve on the type. And if we run this, we will end up with a separation between islands and lakes, because that's what the type field stores. And we can see this if we go into the symbology. We say categorized, classify by type. There we go. And you see that there are two types, island and lake. And if we give them different colors, we can clearly see that here we have a lake and it is now separated out. And there is, look, there's a second lake over here. Let's turn off the grid. We don't need it for these steps. There's a second lake over here, which has two nice towns over it. There's even a ship connection between them. Very nice location on the map here. And we can now use this lake, separate it out, or save this layer and use it for something else. And that is in Mapbox, we can use this to make a background landmass layer, which we will actually be doing. For the buffers, we will keep working with this layer. And firstly, we want to delete. So save this first if you want to use the lakes. I'm just showing how it's done. So firstly, we want to select all the lakes, edit and delete, because we don't need them for the next step. I will turn off all the other things. This is our pure landmass. And now we have a function here in Vector Geoprocessing Tools buffer. A little bit expanded from the landmass. If we pull this under, we begin to see this outline effect. That is what we are looking for. It's not perfect yet, and it also works at the lakes. So that's why we deleted the lakes actually. So it's not perfect yet. It's such jagged here, and that is something we want to remove next. So we take our buffered layer, we go to Vector, Geometry Tools, Simplify, and 0.2 works for me. In case you wonder, I use commas because I use German operating system. If you're using an English American operating system, of course, it is actually 0.2. And again, you need to play around with this a little bit, because on this map, it seems that maybe 0.2 is a little bit too aggressive, but let's stick with it for the moment. Because we're not done yet, we go to Processing Toolbar, and there is a function called Smooth. Maybe 2 steps is fine. Everything else we leave at the default values. We make sure that we use the simplified layer, and we end up with this smooth layer, which actually is pretty good. So we zoom out and we can see that, yes, we have a nice buffer around our landmass. And in Mapbox or whatever other tool you use to put it on the map, we will just color this a light blue. Then we will repeat this whole step with a bigger buffer that we will color with a slightly darker blue, and so on. We repeat this 2 or 3 times, and then we have a very nice buffer zone. This is my cat, and he's the reason that you are not getting a face video for the end of this tutorial. We went over refining the map in QGIS, and in the next tutorial we will be looking into Mapbox again, how all of the things we did today are brought into Mapbox and made beautiful there for presenting them on the web. And then we will go into the MediaWiki part to integrate everything with text and descriptions and make it interactive. If you want to support this guy and me making more tutorial videos, then please subscribe to me on Patreon. Also, don't forget to subscribe and comment these videos on YouTube. See you very soon. Bye bye.